today was another running day. Like I said, I'm going to try to do more of those. They look better in the morning. I don't know why it's gross now. But went okay today. All we did was I actually switched it up a little bit. So instead of doing the kind of laps, so instead of like structuring it like, okay, straights and curves, we did it for time. So could be getting this wrong, but I'm pretty sure it was like 40-second jog, 20-second sprint, so all allowed that you could do, and we did that for 10 minutes. So a little longer time, but there was a little more room for rest. You're still jogging, but did not enjoy it too much, but it went okay. I cannot wait till this starts to feel easier, because right now it is really hard to do them, but I know it'll all be worth it, maybe, hopefully. But today, talking about the heart a little bit, going into one of the most important parts of the heart, or what I think is, just from what we learned about cardiac output, which is basically how much your body can pump blood through the body with one kind of like heartbeat, basically. So like liters per minute, I believe, is the unit for Q. So Q, cardiac output, its equation is Q equals heart rate times stroke volume. Heart rate is obviously just how fast your heart is beating. It's going to be controlled by those nerves, the sympathetic, parasympathetic, accelerator, vagal, like we talked about last time, I believe. Accelerator is going to tell it to speed up, vagal is going to tell it to slow down. There's actually this really cool kind of reaction that happens when you exercise. So what's going to happen is, it's like a car. So like when your body's exposed to exercise, you're not going to immediately go from vagal nerve to accelerator nerve. What you're going to see is vagal nerve is going to shut off and then allow the SA node to fire to 100 beats per minute. And if that can get the job done, cool, it's done. That's what it's going to run at until you force it to slow down or speed up. If 100 beats per minute is not enough to maintain the workload that you're trying to put on it, that's when accelerator nerve turns on, tells it to bump faster, increased heart rate. Stroke volume is really interesting. It's basically how much filling and like push you get out of it. It's going to be driven by Frank Starling law, which is basically like rubber band theory, I guess is what you could call it. But basically, it's the idea that bigger stretch you get on that heart, so the bigger it can kind of fill down and then push out, you're going to see a better contraction and more blood flow out. So basically, the main parts of stroke volume, you're going to see preload, contractility, afterload. Preload is going to be how much passive filling you're actually going to see go into the ventricles. So how much blood can just go into the ventricles and kind of chill there. Contractility, exactly how it sounds. The strength of your ventricles to be able to contract and drive that blood up and out through your body. Afterload, kind of a weird one. It's called, can be defined as like aortic resistance. So basically how resistant your aorta is to blood being pumped through it. So it's really the only one in the whole like preload, contractility, afterload, that as it increases, you're actually going to see a decrease in stroke volume. But yeah, those are the main portions of cardiac output.